Tuesday, we worked a bunch of homework, and we'll continue doing that, right? Some people, so this may sound familiar to you. Some people last hour said, "Guy, you know, I'm okay in class. I feel pretty comfortable, and then I go home and it just sort of falls apart." Right? That's okay. It's like puberty. It sucks, but it's normal and natural. So don't worry about that. What you want to get to what you want to be able to do, if that's you, is keep drilling as much as you can, because what you'll start to see is the big picture through the messy details, right? If, on the other hand, you tend to see the big picture, you say, oh, it just clicks for me, your job is probably going to be make sure that you slow your thinking down so you don't skip over anything, okay? All right, so here's what let's do. Let's say, so chapter 7, we've got 2 connectives. The conditional, in terms of truth tables, the conditional is often called the material conditional. We're not going to worry about that distinction. And the symbol is the one-way arrow. And then the other connective is the biconditional. And yeah, as you can probably tell from the language, it's a two-way arrow. Here's some fast and dirty ways of thinking about the conditional and the biconditional. Your conditional is an if-then sentence. The if part is called the antecedent, and the then part is called the consequent. It's also the case that when you're looking at ordinary language sentences, you oftentimes have the antecedent articulated by if, but you don't have the then explicitly articulated, right? So you could say something like, you know, if you're really tired, you'll likely just jot down some notes or take photos and deal with it later. Notice I said, yeah, I asserted a conditional claim, but I didn't use the word then. It still is a conditional, right? And then the other is the biconditional, if and only if. Another way you can think about the biconditional is that it asserts what's known as a necessary and sufficient condition, right? So we'll talk again, we'll keep filling in sort of as we're talking about this stuff. So think about the difference between the two this way. The conditional antecedent expresses a sufficient condition, enoughness, if you will. So we could say, for example, that drinking water is sufficient for me to have something in my stomach, right? Connor, what are you thinking?
That's not water, Mia.
Oh, yeah, sorry, tea, which is comprised partly of water. Would that it were something else. It does look a little whiskey-ish, doesn't it?
Yeah, that's right.
Yeah, it's not whiskey.
Whiskey doesn't foam.
What?
Whiskey doesn't foam.
Thank you. And not only that, I hate whiskey. I'm not the whiskey drinker in my family. Now, if this were clear, there's a water bottle that says something like, I'm 99% sure this is water.
No.
Okay, so thank you, Connor. Drinking tea is sufficient for me to have something in my stomach, right? It's not like I say that I must do this, right? But drinking tea guarantees there's something in my stomach. So if I drink tea, there's something in my stomach, right? What are you thinking, Connor?
This is actual confusion. For the conditional, it's always true unless the antecedent is true and the consequent is false, right?
Right. So when the antecedent is true and the consequent is false,
then the
conditional is false.
Okay.
Now, there is a world of philosophy on the conditional and related concepts. In fact, I was on the East Coast for a bit. In fact, Remington, I was talking about this earlier. Yeah. So I was close to Brown University, and so I'm looking at their schedule, like, ooh, maybe I could go see if I can sit in on a class, blah, blah, blah. And they had a whole seminar devoted to the conditional. I was so excited. I totally wanted to go, but I didn't get to go because I had to work. Boo. So articles, books have been written about the conditional. One of the questions about the conditional is it really truth functional? So we'll come back to this later, but since Connor's brought this issue up, it's certainly worth talking about. Namely, isn't it the case that we can find some examples where it's not the case that the truth table definition of the conditional lays out? Yes, we can, right? So so I won't give you the example, I'll just give you like row 4 of the truth table. False antecedent, false consequent, true conditional. It feels counterintuitive, right? But when we look at examples, like, so for example, if Pierce is in Paris, France, then Pierce is in Europe, right? It's false that Pierce is in Paris, France. It's false that Pierce is in Europe. But if it is in Paris, France, it's in Europe, right? We think of that as still a true sentence. But then we also sometimes think, well, wait a minute, that's counterintuitive. Can I come up with false antecedent, false consequent, and a false conditional? In other words, there's debate over whether or not the conditional on the truth table, it's a material conditional, is really truth functional. What do you think, Connor?
I'm just confused because if the antecedent is false and the consequent is true, it's a true conditional. But
Yeah.
that seems even more counterintuitive than the other one, right? Because
Yeah.
how can something be consequential of something not being?
So so Connor has just honed in on what seems to be the crux of talking about the conditional as a truth functional connective, namely that we think of, go back to my drinking water example, we think of there being a dependent relationship between the antecedent and the consequent. The consequent depends on the antecedent. But remember, in a truth table, the atomic sentences values contribute to the value of the connective, but it's also, if you will, the meaning of the connective. So here's a way to think about the issue, although it may not be satisfying, and we will want to come back to it. You know what makes an argument invalid, correct? An argument is invalid when the premise or premises are
true,
and the conclusion is false. So if the premises are true and the conclusion is false, the argument is invalid. The conditional, the material conditional, has truth values that reflect the concept of validity. So you can have true premises, true conclusion, right? You can't have true premises, false conclusion. You can have false premises, true conclusion. You can have false premises, false conclusion, right? So rows 1, 2, 3, 4 of the truth table, right? So what we're saying with the material conditional is it mirrors the concept of validity. The only row on which the conditional is false is the row where the antecedent, analog premise, the consequent analog conclusion, true, false. So not maybe very satisfying when the premises are true and the, when the premises are false and the conclusion is true, the argument's still valid, the conditional is still true. There's all sorts of wonderful things to talk about with the conditional. Super exciting. Also gets into like causation, and then you can talk about like modal logic, counterfactuals. Super exciting. All right, but for right now, I mean, does that at least give you a little bit of a weigh in?
Yeah.
Okay. Let's talk more though about why we use the conditional. Short story is it's a shorthand, if you will. It also reflects the way that we talk when we use hypotheticals. So here's a truth functional equivalence, which I'm, remember, symbolizing this way. Our textbook, remember, symbolizes the truth functional equivalence with a parallel set of lines and the arrow. I just want to make sure we're not confusing that with this symbol, even though we will see that the biconditional symbol does really say truth functional equivalence. Hold on to that. But if then is equivalent to either not P or Q, right? So if then P arrow Q is equivalent to either not P or Q. Now, if and only if I'm going to give to you this way, and then we'll look at another way in a little bit. When I say if and only if, I'm saying, look, either I have both or I have neither. Right? P and Q are like Tweedledee and Tweedledum. You see Tweedledee and Tweedledum together all the time, right? And whenever, so whenever you see Tweedledee, you see Tweedledum, and whenever you see Tweedledum, you see Tweedledee. You see them together all the time, or you see neither one of them. I'm so sorry, I'm seeing Connor going like, he's walking through it. Here we go. If I have P, then I have Q, and if I have Q, then I have P. So another, yeah? So you can see certainly from the truth functional equivalence here that the biconditional symbol is a lovely shorthand, right? Just makes writing out the joint necessary and sufficient condition that much easier. Okay. P.S. We can also say this, right? We can also say you just write a truth functional equivalence all day long. Isn't it fun? Yes, me, it's great. Okay, so Miguel, what are you thinking?
So the arrow is just if, right?
Yeah, if then. So the left side of the arrow gives you your if, the right side gives you your then.
So how come we're not using if, then, wait, say that again, sorry?
The left side of the arrow, so you'll go P arrow Q in terms of the, yeah?
So how come we're not using if and only if? You said either we see both of them or we see neither of them. Right?
For the biconditional.
Mm-hmm.
Yes.
So when you said we see Tweedledee and Tweedledum, like we see both of them,
Yes.
but we don't see either of them?
Yes.
So, okay, never mind, I see it. But my question was going to be like, shouldn't we be saying if and only if we see him, we see the other one?
Loosely, another way of saying this, I think this is what you're after, right? So so if we see Tweedledee, we see Tweedledum, and vice versa. Yeah. You know, so one of the tricky parts is this. Lots of times, to try to make sense of the concepts, we'll use some ordinary language examples. So what we try to do in those cases is to use actual sufficient conditions, actual necessary conditions, where we're either talking about physics, or we're talking about, let's say, stipulated sufficient necessary conditions. For example, nothing in nature says that 60 units is required for transfer, right? That's a convention. We've made that up and we've standardized it, right? So that would be a stipulated or conventional necessary condition, right? So, but one of the tricky parts is making sure that we get them right. So, for example, oxygen is necessary, but not sufficient for us to be alive, right? So then you say, okay, so what are in nature or in biology, in this case, the joint necessary and sufficient conditions for being alive, blah, blah, blah. What are you thinking?
So, well, that sentence is true if we use if and only if, would it be more precise?
It depends on the circumstances,
I'm talking
right?
about still Tweedledee and Tweedledee.
Oh.
It's like we only have Tweedledee if and only if we have Tweedledum.
Yes.
So
So
we could use a biconditional for P and Q. Let's just
Like
say.
the both would be true, but one would be more precise than the other.
oh well in the case of Tweedledee and Tweedledum, I'm saying, I don't know if I'm right. It's been a while since I've read Lewis Carroll, but I believe it's the case that Tweedledee and Tweedledum are inseparable.
Mm-hmm.
So where you have the one, you have the other, and vice versa. The way that another way the language is used, although I personally find it counterintuitive, but that's just how my mind works. The phrase "just in case," Tweedledee is there just in case Tweedledum is, which is the biconditional. So it's not working for some; it's working for others. What are you thinking? Connor?
So could you say instead of P conditional Q conjunct Q conditional P, could you just say P biconditional Q?
Oh yeah, these are truth functional equivalences, right? So let's do this just to complete the circle, right? So P if and only if Q.
Okay.
And
That's what I was-
So would these be considered De Morgan's equivalences?
these are not De Morgan's equivalences, no. So from the standpoint of the truth table, Connor, just to wrap these up. Okay, so we know that we have true, true, right? So true, false, false, true.
Yes.
Why? Because when the values are the same, the biconditional is true. This is an equivalence. What do we mean? Equivalent values, right? Whereas here, I almost just swallowed that. Right? So I know normally I just circle the who's he, what's it, the value under the connective, but for right now I'm gonna do this and see if this helps a little bit. What do we think? So there's a truth, I don't know, Miguel, if that works for you, but this is a truth functional way of saying, look, when I have Tweedledee, I have Tweedledum and vice versa. So when one's there, the other one's there, and if each one is, or sorry, if one's not there, then the other one's not there. I know I'm now using the language of negation, but you don't look like you're super enthusiastic, but that's okay.
I think his question was just like, would it not be better to use the biconditional in this case?
Oh, and that's, so then Connor said that, and yeah, well, so partly the reason why if unless I've missed something, so remember the Boolean connectives, right? George Boole developed these, negation, conjunction, disjunction. Those really, we that's it. We don't need conditional and biconditional. Our system is complete without them. But as you point out, the biconditional is a shorthand way of talking about the combinations, the relevant combinations of negation, conjunction, disjunction. And the conditional is, at least so far as the way I think about it, it's so often used, right, that it seems reasonable to say that we more often assert the conditional than we do either not P or Q, for example, right? So, you know, if you go to the movies, I go. Either you don't go or I go. That either you don't go or I go feels less intuitive, I think. Yeah. All right. So, and again, we have more work to do here. There's all kinds of fun to be had. I know, but just so that we can start employing our rules, you have them on your rule sheet, but let's talk about them here, namely the intro and elim rules that go with our new connectives. So we have conditional intro, and we have biconditional intro. And as you can imagine, we have conditionally lim. Is the monitor in the way for you guys? Anybody? I'm thinking of Omar and Kyle in particular. Maybe also Armand, I'm not sure. You good? Okay. And then biconditional elim. So very briefly, we've already got two strategies, right? We've got a set of rules, intro and elim, but two strategies for setting up a derivation. We've got, in the order we learn them, disjunction elimination and negation intro. Right? So this is what you do when. Well, now, this is so awesome. We've got two more structuring subproofs, or two more strategic rules. Okay, so think about what the conditional says. The conditional says, if I have P, I have Q. Right? What is an assumptive proof? An assumptive proof says, well, let's assume I have this sentence P. If I have P, then I derive Q. So I've just proven on the vertical what I'm asserting on the horizontal. If I have P, I have Q. Right? So here's the strategy. When your conclusion is a conditional, set up conditional intro. Isn't it awesome? Yeah. Conditional elim, you already know. When you affirm the antecedent, and P.S., it must be the antecedent that you're affirming, you derive the consequent, right? If P, then Q. I have P, therefore I have Q. Excuse me. And again, don't forget the way that we laid out the rules on the board and then on your rule sheet. Looks a little bit different from what you see in the textbook. We still want to talk about the textbook presentation of the rules, but this visually might be a little bit easier at first. So why is it that you're not allowed to affirm the consequent? And by the way, it's an imposter, it's an invalid argument. Well, well, that's one reason why you can't affirm the consequent and pull down the antecedent, namely, it's not valid. The inference isn't a valid inference. It's not a legitimate inference. The truth table tells you that you will have a row on which your premises are true and your conclusion is false, right? So there's that. Think about an example, right? If I have P, if I have pennies, then I have quarters. I have pennies, right? So now remember, sufficient condition, I'm guaranteed quarters. On the other hand, if I say, if I have pennies, then I have quarters. Oh, I have quarters. That doesn't guarantee that I have pennies.
But if you had a biconditional, that's where the biconditional
Yes,
is. Okay.
yeah, right. So now I gave you the PQ. Think about it this way. Let's kind of bring to bear what we already know in terms of coinage. If I have 10 pennies, I have 10 cents. Right? We know what our denominations are, right? We know what our coins are. So if I have 10 pennies, I have 10 cents. I do have 10 pennies. That guarantees I have 10 cents. If I have 10 pennies, I have 10 cents. I have 10 cents, therefore, I have 10 pennies. Right, you're all going, no. Because you can come up with a counterexample, right? You could have 2 nickels, a dime, a nickel and 5 pence, right? When you can falsify that conclusion, you know that the argument isn't valid. Okay, so it's got to be an affirmation of the antecedent. Now, as Romton rightly points out, and we'll come back over here to make sense of this, the biconditional elimination says, look, you can, it doesn't matter what side you affirm, you can pull down the other side. Why? Well, think about it. If the biconditional is a joint conditional, right, you can dismantle the conjunction and affirm on the assumption that you have P. You can pull down Q. Or dismantle the conjunction on the assumption you have Q, you have P. So you can get to each one. Okay. Now, I want you to use your prodigious skills and anticipate, based on what you know, what you've been told just now, that this is a strategic rule. What do you think the biconditional intro is going to look like? You want P biconditional Q. What are you going to do? Don't be
You
shy.
have to get P and Q.
Yeah,
In
you're
two-
going to have
in
to
two
get
different, that's the subproofs or subproofs.
two different subproofs. Yeah, did everybody hear what Rumton said? You're going to derive Q from the assumption P. Then you're going to turn around. So these are successive subproofs. Then you're going to turn around and derive P from Q. So you can say, well, if I have P, I have Q, and if I have Q, I have P. I have P if and only if I have Q. Is that awesome? Sorry, I'm only laughing because the look on Janet's face, her eyes are saying, this is not awesome. If it's the case that I'm right, then remember, I'm yapping at you. I know we're not walking through this in the slow way we did, right? The other rules. Moreover, we're not explicitly walking our way through this by way of the truth tables, right? So, oh, and it may just be that you're tired, or it may just be that you're distracted. It doesn't really matter. I would say, just live with it, and it'll get better, and we'll keep coming back and filling in blanks. But I think we should start practicing. What do you think? Yeah, it's gonna be super awesome. Okay, so I'm doing my usual. I'm just stealing from another book. All right. What do I want to start with so that we can feel pretty good? Oh, I know. Hold on just a sec. I think this is right. Okay. Okay, so we're told, so I'm thinking about what rules might feel to you the most intuitive. So we're told that we have either P or T and R. We're also told that if we have S, then we have neither P nor T, and we want not S. Okay, so here's what you're going to be thinking about. You're going to be thinking about the strategies that we've already talked about. Why thinking about strategies? Because that's how we set up, we make a roadmap for a blueprint, a template to follow. We've got two options, right? We want not S, so we can assume S, derive a contradiction, get out. Alternatively, we want not S, we can assume P, derive not S, assume T and R, derive not S. Right, so disjunction elimination or negation intro. Doesn't matter. You already know this. This is not new. So what are you thinking? Rampton wants negation intro. That's his favorite. Okay, we'll start with negation intro, then we'll go do it the other way. All right, so we're going to assume S. We're going to derive a contradiction so we can get out and say, our assumption was false or is false. Okay, so that's line 3. What do we do? So now let's think in terms of either further strategies, or let's think in terms of our process of assembling and disassembling. We want to dismantle that disjunction. We also want to dismantle that conditional, right? Now, you could dismantle the conditional, or you could immediately go to your disjunction elimination subproof. What do you want to do? You tell me. Pick one. Okay, dismantle the conditional. So Ramton's saying, hey, we notice we've affirmed the antecedent, so that means that we have neither P nor T. And let's go ahead and mark these. So we use 2 and 3, conditionally lim. Remember one of the learning approaches we talked about, and that is, you know, when we're working, look at your rule sheet, look at the proof. Look at your rule sheet, look at the proof. So that you can start seeing the form of the argument, whichever it is, whether it's a strategic or a tactical, in the midst of this particular individual proof. Okay, now we know what we want. We want a contradiction. We have a negation. Wouldn't it be cool if we had P or T so that we could say there's a contradiction and then get out? Okay, so how are we going to get P or T?
Disjunction of lim.
We're going to disjunction elim line 1, right? So we're going to assume P, what do we want? A contradiction. And then we're going to assume T, what do we want? Or sorry, what did I say? T and R, sorry. T and R, what do we want? A contradiction. So that, notice where we are, why do we want notice where we are, we're in a proof whose conclusion is a contradiction. We're always working backward. If we want a contradiction, we need to figure out how we're going to generate that. The only way to generate it is to dismantle the disjunction. Okay? So what do you think we're going to do now at line 6?
P or T.
Yep. So line 6 is going to be P or T. Line 5, oh, we didn't cite the numbers here, did we? So 2 and 3. And then here at 6, it's going to be 5, disjunction intro. And I'll go ahead and check this off, right? Now, we've got a contradiction from what? 4 and 6. So this is line 7, 4, 6, contradiction intro. Now we're done with that subproof. Okay, are we ready for the next one? Okay, we're assuming T and R. What do we want? A contradiction. What do we want to contradict? Neither P nor T. So I can dismantle. I can assemble. And I can assert. Okay, is everybody with me here? Line 9, 8, conjunction elim. Line 10, line 9, disjunction intro. Remember our subproofs, let me rephrase that. Our successive subproofs either entirely or almost entirely mirror each other. Line 11 is 4 and 10, contradiction intro. And now we're back out. Line 12, 1, here we are. Sorry, I stopped checking those off. Do you want me to check them off? So we did our contradiction. Then we eliminated, we introduced, we generated a contradiction, and then the 7 and 11 as the end of the subproofs are going to get folded into our disjunction elimination citation. So 1, 5 to 7, and correct me if I've got the line numbers wrong, and then 8 to 11, disjunction elim, and then 13, 3 through 12, negation intro. So what have you noticed? You've noticed you're just adding a little bit to your repertoire of super awesome skills, right? These last 4 rules, the 2 sets, 1 for each of our new connectives, gives us more efficient ways of proceeding at times. What do we think? How many of you said, yeah, okay? I don't know. So Kevin, I'm not sure what to make of your expression because you're smiling, but you're also shaking your head. Can you, so a little bit of trouble?
It's more of like the sub.
The nested?
Yeah, nested.
Okay. All right, good. So this is a good start. Question for you. So just to reiterate, you're comfortable with the strategy. When you say that the nested subproof bothers you, can you, like, what's happening for you?
So for the I see it for like disjunction intro. I try to make a contradiction, right?
Yes.
But like say for like line 9 and 10.
Yes.
How did you come with that? Where did that come from?
Okay, so let me reiterate and see if I've got you right, because I think if I do have you right, you're on to something really important in terms of how our minds work. Okay, so I'm hearing you say that the first of the disjunction elimination subproof sequences feels comfortable for you, right? If I have P, I have P or T. There's my contradiction. Done, move on. Now this is where things are a little iffy. Me too. Me too. So am I right to think that you weren't on board in advance seeing the elimination, then the introduction, which gives you your contradiction? Is that fair to say? Me too. Okay, so here's what I want to know from you guys. For those of you who saw it, how did it work? I can tell you what I did. I said to self, hey, you know what? It's a valid argument, and unless you've made a mistake somewhere, you're going to freaking generate a contradiction. It's going to happen. So where is the contradiction? Well, the contradiction has to be here. So I established a sentence and it has to contradict this one. Why? Because there's no other freaking negation anywhere. Like, I have no other choice. Okay, so if it has to be P or T so that I have the contradiction right here, then that means that I have to have P so I can introduce T, or I have to have T so I can introduce P. Oh, I do have T. Here it is. I just forgot about it and I have to dismantle it. That's what I did. It's like make like a shark. I'm moving. I'm looking. Where's my contradiction? I got to find my contradiction. That's my prey. Connor, what are you thinking?
Why do you have to cite S when you're doing conditional elim for step 4?
Oh, okay. Can I pull it off to the side?
Yeah.
While I'm pulling it off to the side, Rampton, tell Connor what you're thinking.
Oh, because if you when you eliminate condition, you have an S and not P or T.
Yeah, but don't you have that in 2?
But 2 is a premise. So if you break the premise up, you need S and not pure T. Therefore, you have S, so you cite it. You know what I'm saying?
I think I
But think of it as like disjunction of them.
Okay. Okay, yeah.
So how about something like this? So if I study really hard, then I'm neither I'm not either, or I'm neither. That then it feels awkward. I'm neither going to the party nor taking time off. Okay, so if I go to the if I study really hard, then I'm not going to the party and I'm not taking time off. I'm doing neither one of these things. In order for me to say that I'm neither going to the party nor taking time off, I have to say, yeah, and in fact, I am studying. I'm saying it right here.
Okay.
That's the only way to dismantle this. So think about your conditional elim and your biconditional elim as tactics, right? So the only way to dismantle an arrow, and 99 times out of 100 you want to dismantle it, affirm the left side. Affirm the left, derive the right. As Ramtin already points out, on the biconditional, it doesn't matter which side you affirm. That's the nature of the biconditional. What do we think? So far, so good? How about we do this another way? For those of you, Ramtin said he likes that, loves that negation intro, but we're flexible, so we can do this proof a different way. How about we do this? How about we say, I'm going to assume P, what do I want? Not S. Then I'm going to assume T and R, what do I want? Not S. So that I can get out and say, in either case I have not S. Right? Now, once you do that, you're still, or sorry, rephrase, because I was going in a grammatically peculiar direction. Your conclusion is a negated sentence, right? What do we do when your conclusion is a negated sentence? Yeah. Right? What do you think is going to happen? Same stuff you were already doing. Sorry, let me move this down a little bit. It's my usual not making enough room. So, Ramtin, you still get your beloved.
There's like an extra step involved. You know what I mean?
Yeah, that's okay.
Yeah.
Well, the logician's going to say that the most elegant proof is the one with the fewest lines, right? Without glossing over anything. But it's still he likes that idea.
Yeah.
But it still is going to be the case that this is correct, right?
Absolutely.
So T conjunction R. All right, now what are we going to do? Can probably imagine. Saving your little horn. So now you've got a couple of options here, right? You can go ahead and eliminate the conditional if you want. You can go ahead and get your T and then get your P or T, or you could get your P or T first. Four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So somebody might say, why did you go on and on? You could have got there faster. Yes, but we still got there legally. What do you guys think? Here's a question for you. obviously, no citations or justifications have been made to the version of the proof we have on the right. What's our thinking there? Kevin, what are you thinking?
I'm just wondering, what were the strategies called again for each one?
So we have negation intro, we have disjunction elimination, and within each we have just conditional elim in terms of our new tactics, right? So given, they're all assumptions, right? So line 5 comes from 2 and 4, conditionally elim, right? Line 6 comes from 3, disjunction intro. Line 7 comes from 5 and 6, contradiction intro. Line 8 comes from 4 through 7, negation intro. Assumption, the first inference at line 11 is, again, notice the mirroring, 2 and 10, conditional elim. Then 12 comes from 9, conjunction elim. 13 comes from 12, disjunction intro. 14 comes from 11 and 13. Please correct me if my lines are off. Contradiction intro. And then once again, 15 comes from 10 through 14, negation intro. And then to answer to write down the answer to Kevin's question, 16 comes from 1, 3 through 8, 9 through 15, disjunction elim. Assemble, disassemble, assemble, disassemble. Angel, what are you thinking?
Is line 7 off? Shouldn't it be 5 and 6?
Oh yeah, thank you. I wrote 6 and 6, didn't I? Again, thank you for pointing that out, but it's another, I hope, nice reminder to us that whether we're talking about verbally articulating a thought or we're just working quietly and we're thinking something but we write something else, these things happen, right? Don't beat yourself up over it. In addition, right, depending on how you're feeling, don't beat yourself up. Like somebody said, oh, I just came off of work, I'm so exhausted. And I said, okay, so today's not a great day for you right now. Here's what I recommend. Either write these things, write down what we're doing on the board, write it down on a piece of paper or take photos. Go take a nap, right? Just sit here and go like this and then, and when you're rested, come back to it. I mean, you're not machines, right? You can't be expected to sort of perform at peak levels all day, every day. It's just not going to happen. I have no doubt that you guys are dedicated, you're diligent, you're here, you're making the effort. So it's not like I would think, oh, I got to beat you up because you're slacking off. That's not, you're allowed to say, I don't get it yet, or I'm having a bad day. Okay. Kevin, question for you. I think I'm right here to when I say, isn't it true that you can see those strategies? Yeah, you okay with those? Okay.
Yeah. It just like you're saying, I see it when you're doing it, but like when I try to do it myself, it's like kind of mixed.
That's okay, because that says to me you are so close to it just cracking wide open. I'm telling you, once it cracks wide open, guys, you're going to have, so do you mind if I mention a part of our conversations? Absolutely. So Ramton and I were working a little bit this morning before class, and he said, he's working, he goes, oh, duh. And I said, well, yeah, it feels like duh, but it's not duh until it clicks,
well,
right?
I lost it again, actually.
You like, I love it. But here's the thing, when it really, right, I think that the coming back to it will be much quicker. Yeah. It's what happens to me a lot, and I can blame it on all sorts of what I will call woes of my life, I'll miss something and I don't get it, and I've been doing this forever. Why am I having this trouble? Blah, 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 blah. But the reality is it's there. It's just I have to bring it back, right? But I think once it really clicks you and it seems obvious, once you're there, even if you're having a bad day, it's okay. You'll come back to where you need to be. You are so close. So close to it, just cracking wide open. We ready for more practice? Yeah, because it's so much fun. How could you not want to do more practice? One of the things that you might consider doing if you're feeling like Kevin has very generously shared, if you're feeling as he has shared he feels, you might consider working proof completion. So don't forget, even though it might seem like it's a drag on your time to do the you try it's, I promise you that investment of time will pay off in the long run. In addition, don't forget on Canvas there are additional practice exercises. There are documents with additional practice, including proof completions. Okay, so what do I mean by that? Well, let me show you. So here is P arrow Q, then R conjunction S, then P, R, and we want S arrow Q. All right, so this is what I mean by a proof completion. Granted, on the exam, there's not the color coding that I'm doing on the board, but I don't think by the time we get there that that's going to be an issue for you. Okay. So then we will do this. Paying attention, I didn't anticipate that we're done. Okay. Oops.
Why do we group into three?
The second one.
The second
On
one?
your right.
Is it?
Huh?
It goes
It goes
1
1 to
to
3.
Oh, because I don't know.
Okay.
Because I saw a number 2 and I meant to go right over the number 2 with the green number 2, but I saw the number 2, so I wrote 3.
Is it the same as the other one where there could be a 6?
Thank you. Yes.
Okay.
Yeah.
Just making sure.
There is. I mean, apparently, I'm not aware of this, but apparently, I do have reasons for what I do. I just don't always, right? I have no idea what's going on by and large. Okay. And then we say not P conjunction, not Q, then R. Okay. So let's look at this guy. First off,
I thought it was going to fall.
All right, so green is our structuring subproof, right? Kevin, no nested subproofs, right? All right, so we're assuming S, we're deriving Q, so if we have S, we have Q. Yeah? What are you thinking?
So would the first step for 5 be conditional elim based off of number 2?
No.
Great question. And you know what's so interesting is a lot of people will say that. The answer is no. Brampton's right. The answer is no. Remember, so this is the tricky part. In order to deal with this sentence, we have to either have denial of the consequent, or we have to build the antecedent.
Okay.
So let's do it.
So it would be content intro from R&S.
Yeah,
Okay.
so we're building, right? So remember, we're earning our antecedent, so we're saying 3, 4, conjunction intro.
The next one is
Yeah.
Now,
okay.
there you go, good. So then 2, 5, conditionally limb, right? Then 1, 7, conditionally limb, so that 4 through 8, conditional intro. What's our thinking here? So here's the way that we want to think about our conditional. When your conclusion is a conditional, assume the antecedent, derive the consequent, assert conditional intro. Do you have to do that all the time? No, but okay, that's the standard strategy. Shoot, sorry, there was something else I was thinking, now I can't remember. Oh, sorry, the other thing is when you're given a conditional. So there's a difference between making a conditional versus dismantling one that you're given. When you're given a conditional, think dismantle, think separate, eliminate, which is why you want to assemble that left side. Okay, how are we doing? Are we ready? All right, so here we are on the next one. Here I go again. Crappy McCrapperson. Here, how's that? I'll do that. Then I got more room. So then I can do what needs to be done. All right. Hold on. 5, 6, 7, 8, 9, 10. Okay. Proof completion. Right? So I think if you say, hey, yeah, Mia, completing proof's not so bad. I'm comfortable. The more you drill those, the easier it gets. And if you run out of practice, I got more. Okay, who's ready to start filling in? Tell me when you've got down what you need to get down. We'll start filling in. And tell me if there's something you can't read either. What are you thinking, Connor?
So would 3 be conjunct elimination, and you get that from 2?
Yeah. So 2 to 3 is conjunction elimination. Okay. What's next?
Conditional limb.
Conditional elimination from what and what? 1 and 3. Good. I derived a disjunction. What do I do with disjunctions? Yeah, sorry, erase this. Eliminate them. So in each case, right, so I'm doing this. I'm saying, okay, I've got this. I'm going to assume the right side, get R. Or sorry, assume the left side, get R. Assume the right side, get R. Miguel.
Why is it conjunction elimination?
Oh, the conjunction.
Oh, sorry.
Yeah. No, yeah, you were up here?
Yeah.
Okay, good for you. So now what do we think about, I know the writing's kind of small, but what do we think about 6? Miguel, that's for you. Number 6 says not Q. Well, let me ask you this. Where does not Q appear?
On line 2.
Yep.
Conjunction elimination.
Yep. Now what happened? Line 7. Contradiction intro, really nice. What are our citations? 5. Remember, you dismantled 2, so now you've got, remember your contradiction has to be a sentence and its negation. So you got to isolate the not Q. And then what do we do from a contradiction? Anything follows, right? And what do we want? We want R. Why do we want R? Because that's our goal in the subproof. What did we do at line 10? Reiterated, yep. If I say I have R, I've got R. And now we're out. So we have disjunction elim from what, and what, and what, and what?
5 to 8, 9 to 10.
Yeah, 4, 5 to 8, 9 to 10. So now I can say what? We set up
Conditional intro.
conditional intro from, what was it, 2 to 11. Whoop, whoop.
So we don't have to cite 1
We did.
for number 12.
Oh, I see, no.
No.
The snarky answer is, it's not what the rule says. But the more appropriate answer is, it was cited within the subproof.
Oh, okay.
So it was employed.
Okay.
Yeah.
And if you did cite 1, it would not give you the green check mark.
Correct. It'll say, what are you doing? It's one of the nice things about Fitch is that it's right there with you to confirm that you're correct, or even if it doesn't tell you why you're incorrect, it'll at least tell you that you're not correct. So that's kind of nice. Yeah. We ready for another? Yeah. Natalia, what are you thinking?
I'm so confused for line 4. Why are we including 3?
Oh, okay. So line 1 is if not P, then Q or R. And then line 3 is the affirmation. Probably, yeah, it was a little light. Yeah. What do we think? So far, so good? I know, it's so much fun. You can't stand it. I'm just jealous of you guys because you're going to be having so much fun this weekend. Oh, boy.
You can do some of these too.
What?
You can try some of these.
Maybe I will, yeah, just for fun.
Just a guess, but I think she's an expert.
No, remember, what's the class mantra? If Mia can do it, I can do it. All right, there's no expertise here. This is just this for me is just the result of being a workhorse. I mean, philosophy is a big discipline. There's stuff that I love and that resonates with me, and there's stuff that I just have to work really hard at. So yeah. This is just years and years of doing this, and you guys are way ahead of me. So you don't need years and years. You're gonna get this in the semester. All right. How about this one? Let's do this. Let's make sure I've got this right. If P or Q, then S. We could also do ordinary language examples too. That might be fun at some point. Just to bring it back to something that's maybe feels a little bit more tangible. R, P, or Q, which actually, sorry, I'm pulling out of this textbook. We don't need to do we don't need the parentheses. R, not R, and not T on R, and then S if and only if T. Strategy alert, strategy alert, strategy alert. When your conclusion is a biconditional, use biconditional intro. So that you can get out and say, I have S if and only if I have T. Okay? How are we doing? So far, so good? Now, there's more than one way you can move forward, but what I would like us to keep practicing, because I think in the long run, it's just the best way to approach the system that we're learning. Work backward, right? Your goal is T. What do we do when we have an atomic sentence or a negated atomic sentence? Right, negation intro. And notice here, maybe just for space, I'm going straight for the affirmed sentence. So this is going to be negation intro. And then on this side, probably the same thing, right? Assume not S, generate a contradiction, negation intro. And we know already that we're setting up biconditional intro. So one of the great things about working backward is this. Ramton's point from earlier notwithstanding, namely, it's possible that you're setting up something that might take you longer than some other setup, but it's still the case that when you work backward and keep setting up, you're filling in the blanks, right? It's a connect the dots sort of thing. At least it feels that way to me, right? The more I can fill in, the easier it is for me to see where I'm going. Matthew, what are you thinking?
How come you cited it as biconditional intro versus biconditional?
Oh, we're creating the biconditional, right? So we're saying biconditional introduction, the generation, the assembling of a biconditional happens when we can prove from each side of the biconditional the other side. Yeah? Okay. All right, so if we have not T, we have R, which means we have a contradiction, right? Okay. If we have T and we have not S, things are now a little bit more complicated, but what do we at least know? Okay, we've used these two. We know that we're going to need to do something with 1 and 2, right? So let me do this just because per my usual, I don't give us enough room somewhere in the proof. T. And then let's move this guy up. Sorry. Okay, what do we think?
Do you have to use conditional one for one? Or can you cite? You can't cite the S, can you? To get a contradiction for S and not S.
Correct. So Romton's asking if within this nested subproof we can go up here. No, because remember, every subproof is contained. Once a subproof has been discharged or completed, it's closed. You can go from not S out to this T. You can go from this not S up to your premises, and you can go from this T up to your premises, but you can't go out into something that's already been discharged. What do you know you need to do? You're right. You need to dismantle the conditional. How do you? So let's think about it this way. Here's what we haven't used yet, guys. We have not used line 1, P or Q, then S. If we can get, I'm boxing this up. If we can get P or Q, then we can get S, and then we have a contradiction. Sorry, we have a contradiction. Let me fix that, right? Remember, we pull stuff off to the side as we need to. What else do we know? Well, in order to get P or Q, we need either P or Q. Here's something cool. We also know that disjunction, disjunction, We know we need to eliminate it. Moreover, we know that if we assume R, we've got a contradiction. If we assume P, we can get P or Q and we get S, contradiction. If we assume Q, P or Q, S, contradiction. Holy moly, that was fast. Let's walk through this. So P or Q, I'm sorry, R or P or Q. Assume R, contradiction. Assume P or Q, S, contradiction. Assume Q, P or Q, S, ugh, crappy McCrapperson, did it again. I'm gonna fix it. R or P or Q, right? R, contradiction, P or Q, S, contradiction. Finally, Q, P or Q, S, contradiction. I know, it's not attractive, is it? What do we think? Okay, so here's what we're gonna do. You are either, of course it's up to you, you are either gonna photograph or write this down, then over the weekend, you're gonna complete this proof on a piece of paper and bring it in and get extra credit. Now, don't fall over, Connor. Suddenly the cameras come out.
So me taking photos.
And then, of course, after you've turned in your extra credit, we'll just complete the thing and make sure that we know where we are. And then we're going to take stock. We're going to take stock in terms of what it is that we want to be doing in Chapter 6, 7, and 8. What are you thinking?
After S, would this be possible to cite P or Q for conditional lim instead of starting in that's a subproof? So after S, the green S, the first one, cite P or Q to get conditional lim, then R or P or Q for disjunction intro.
You cannot affirm the consequent. So what I think I hear you saying is this.
To get R by itself and contradicted at 3.
Am I right that I'm hearing you say this? You're saying that S will allow you to pull down P or Q?
Yeah.
No,
It won't.
it won't. That's the short answer.
Okay.
We need to talk about the longer answer,
Okay.
right? So that would be an illegal move. What are you thinking, Matthew?
So
Yeah.
extra credit is just finishing that whole
Yeah, complete this, citations, justifications, just on a sheet of
But
paper.
P or Q would allow you to bring down S.
Yes,
Yeah.
there you go. Yep, good. Oh, have loads and loads of fun. I'm so jealous. Maybe I will just work a bunch of proofs this weekend.